Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Outpost 24. My name is Cody, and welcome back to Techstrong Learning. We have an exciting presentation ahead, but before we get things started, I do have just a couple of notes to review with you. First of all, we are recording today's session. So if you miss any of our conversation, if you'd like to watch again, or if you'd like to share with your team, you will be receiving the on-demand recording shortly after we conclude this live session today, and that will be sent to you via email. If you'd like to engage with us with comments, questions, thoughts, there are a couple of ways to do so. The first and the easiest option is the chat tab. So when you find that chat tab on the right side of your screen, let us know from where in the world you are joining in. If you have any specific questions, there is a Q&A tab on the right side of that chat section. And if you have any questions, we'd love you to send them through the Q&A so we can keep track and answer as many of your questions as possible. We will have a couple of polls we'll be launching throughout our program, so keep an eye out for those as they pop up. Additionally, if you jump to the handout section, you'll see there are some resources there for you, so feel free to grab those at any point during our program. And before we close things out, I will be giving away two $25 Amazon gift cards, so be sure to stick around until the very end to see if you're one of our lucky winners. So our topic today is AppSec 101, Complete Application Security Across the SDLC. And I'm joined today by Stuart Beatty, Product Manager at Outpost 24. Stuart, thank you so much for joining us today on Techstrong Learning. I'm going to pass the mic on over to you and let you run away.
Great. Thanks very much, Cody. And thank you everyone for attending, and welcome to this this webinar on complete application security across the SDLC, or software development lifecycle. So today, software is critical to our businesses. Whether we are writing software as vendors to sell to customers, or writing software for in-house use. So, for example, to make employee-specific software to make them more productive and efficient, or writing software for our customers to use, for example, to access our customer services portal, those kind of things. So regardless of the kind of software we're writing, whether the aims are to make money through selling the software or to become more efficient internally or with our customers, software is playing a critical part of what we do. So, and that's regardless of what business we're in as well. Software is all over the place, and we're using software across organizations. I think about 15 years ago, Mark Andreessen famously said, software is eating the world, and it's still very, very true today. So as a result of software becoming more and more business critical for us, it's critical that we deliver high quality software that's on time, bug free, and free from security vulnerabilities, a topic that we're going to be talking about an awful lot about today. Delivering software that contains vulnerabilities has many, many negative effects on our organization, our customers, and our employees. First of all, things like, I could go listing a whole load of things, but data breaches. Clearly, attackers that gain access to customer databases will cause all kinds of issues with customers, but also with regulatory fines and those kind of things. Loss of intellectual property, whether that's source code, blueprints to a new manufacturing design, or whatever we actually do. Again, bad situation if those get compromised. And also, if the attackers just bring down our systems and stop us from doing our work for a given period of time. So those are kind of the technical side of things, but there's also, as I kind of hinted at, the non-technical kind of things, the financial penalties for breaching various government and industrial regulations. So clearly, not a good situation to be in if we have vulnerabilities, and we want to try and catch those as early as possible, which will help us save time and reduce costs, which we'll talk about in a little while. So today we're going to go through and look at the different stages of the SDLC, or software development lifecycle, and understand where we can introduce security, both from a process point of view and also from a software point of view, to actually eliminate those vulnerabilities to protect our software and to protect our businesses. just before I do, just a quick word about Outpost 24. We were founded in 2001 in Sweden. We are, we provide vulnerability management, threat intelligence, services, products and services to customers. You can see there over 2,500 customers with being supported by over 300 employees worldwide, and already 58 of the Fortune 500 companies are relying on Outpost 24 for vulnerability management, threat intelligence, attack surface management, and those kind of things. So just a quick look at the agenda for today. Basically, I'm going to take us around this this infinity wheel, if you like, just looking at the different stages of the SDLC and how we can fit in security into the different areas. So we'll start off by looking at the how we can help developers with their coding, so that to ensure that they're coding securely, which is obviously the best place to start. That's the earliest place in the life cycle where we can really make an impact. Then we'll go on to looking at the build phase, the kind of testing that we should do during the build phase, particularly focusing around APIs, which are becoming more and more critical within applications and web applications specifically these days, and definitely shouldn't be ignored. Then we'll go as we're going into the test phase before we actually release the product. Very important for us to actually do some manual in-depth penetration testing to make sure that the application we're about to launch or the application that's about to experience a major change doesn't have any vulnerabilities before we actually release it out into production. And when we do come to release into production, we need to be typically now many organizations are using containers. So we'll look at the security aspects around containerization and how we can manage both the containers, the infrastructure side, if you like, and the vulnerabilities of the application, or prevent vulnerabilities within the actual applications they contain as well. And then finally, we'll go in and we'll have a look at how do we continuously monitor the applications once they've been deployed into production. We still need to watch out. We need to watch out for configuration changes, library changes, those kind of things that could introduce vulnerabilities into the organization. So we need to actually make sure that on an ongoing basis that we're protecting ourselves against those. But before we actually dive in, just like to highlight something that I think many of us know, but I think it's worth reiterating, and looking at the cost of fixing security bugs at various stages of the SDLC. This is this information I got from Deep Source. There are numerous different tests, numerous different statistics out there and research out there highlighting this, and they vary, and depending on the organizations they polled, you may have different mileage as well in your organization. But I wanted to show this chart just to show the direction rather than the absolute numbers from that point of view. So clearly, as we go further through the development life cycle, the cost of finding and, more importantly, fixing security bugs, indeed any bugs, becomes more and more expensive. There are many reasons why it's easy to fix things earlier in the cycle. One of the main ones is that these things are fresh in developers' minds. They know where the code is, what bit of code is performing what function. But as time passes and the code becomes more advanced, more complicated, developers need to spend more time digging through the code to find the issues before they can even and re-understanding what the code's doing before they can actually go about fixing it. And recreating those issues in the developer environment also becomes more challenging and more time consuming. And obviously as well, when we get into production, that's a much bigger story. We have real users using the software, and it just becomes more risky to actually change the software. And the applications, the applications were already being run. The users could experience issues with the bugs, be they security bugs or just general bugs. Hence the reason in this particular study, it costs 30 times more to fix security bugs when we're actually in production. So, summarize so far, we don't want to release software that contains security vulnerabilities because of the business criticality of the applications, and we want to find them as soon as possible and eliminate them, preferably before production, but as early as possible in the cycle. So let's now dive into the different stages of the SDLC and look at the different processes and tools we can use to detect vulnerabilities and prevent them from getting into the production environment. So the first stage, which I haven't which I haven't mentioned much so far, is the idea of the planning and design phase. This is very much led by people and process rather than by technology, but this is where new features are proposed, covered, and prioritized. These are typically done by a project manager or a product manager who's responsible for collecting a list of features and pulling them together from various sources: customer requests, competitive analysis, employee suggestions, R&D, whole bunch of places. But these suggestions are all brought together to form the plan and the design for the application. And one thing that's really important to consider here is the idea of the security considerations, because very often security, building in security, is something that needs to be done early because it's an architectural. There are architectural decisions that have to be made. If we suddenly realize down the line that we need some new authentication or new anything, then it's going to be very difficult. It's going to be very difficult for us to go back and re-architect what we're actually doing. So I'll put some examples there of the kind of things that we need to be thinking about. Clearly, data encryption, to make sure that the data is sensitive data is protected both at rest and in transit. The location of where the data is stored, both the country and the security of the data center. Authentication and authorization, looking at who have access to what parts of the application functionality, and also the data that contains. Input validation to prevent things like SQL injection attacks, and API security. So important that we actually look at all of these different angles and make sure we pull in that information. And it's important as well to really consider the stakeholders. We need to be looking at all of the stakeholders across the organization. Clearly, the IT security team and the IT team itself, but also users, business owners, business application owners, and people in the risk and compliance departments who have a lot to say, a lot of influence and a lot of input into this area. So once we've actually designed the code itself, designed the overall application, now we come into the actual start of coding the product. So overall, when I speak to developers, they'll quite clearly want to develop they don't want to develop insecure applications with vulnerabilities in there. They understand clearly how important it is to deliver high quality software without bugs and without software vulnerabilities. However, in my experience, it becomes challenging when there are competing pressures and they have to tread a fine line between different priorities. So what would happen hypothetically if fixing a vulnerability would impact a key delivery milestone? If a developer is compensated, measured on delivering on time, then that's clearly going to be their key focus. And for many organizations, that is the case, because the delivery of the project means either revenue or cost savings or the ability to move on to the next part of the next critical part of a project. So shipping is critically important. So in organizations where this is the case, I've often seen a short-term fix for a security vulnerability with the intention of going back and resolving it properly later on. So basically adding some technical debt that we could do without, and that's probably the best situation, sadly, because I say best, but it's still not ideal. Or that temporary fix becomes permanent, which could expose vulnerabilities, and further down the line. So not a good situation to be in. So if the culture is of delivering to schedule above everything else, then it's going to make the situation actually worse. So in addition to this fine balancing act, if you like, one problem that running at full speed actually can cause us as well. My screen, there we go. Is this thing that I've called the cycle of recurring vulnerabilities. Basically, if we are fixing the problems, I've seen in many organizations that we don't learn from our mistakes and learn from our findings. So in this cycle here, you can see that if I start at locate on the top right, the security expert identifies vulnerability that needs to be resolved. It's loaded into the bug tracking system, Jira or whatever, and then allocated to a developer who hopefully finds the problem, goes back, finds the problem, fixes that vulnerability, and then it moves on to the next vulnerability or the next task. Now that's great because we've actually fixed the particular vulnerability now, but very often in many organizations, that overall knowledge disappears into a black hole because we've moved on, because we're going through very, very quick agile cycles. That sprints over, move on to the next one. And then what can happen in this situation is the problem reappears and we're back to, the bug is reproduced unwittingly, unknowingly, and we're back to where we started again, because there's no organizational knowledge captured in this situation. If, on the other hand, we did capture the information and we did train all of our engineers and developers about the specific problem and the specific types, families, and categories of problems, then best case, the vulnerability wouldn't be introduced again because there's been intrinsic learning across the organization. But if unfortunately it is introduced again and the security expert finds it again, there should be some organizational knowledge there that allows us to fix the problem that much quicker, so we can actually get around the cycle quicker. So this idea of learning about learning within the organization to speed up, to prevent bugs, or to actually speed up the fixing of vulnerabilities is also a critical thing that we need to be considering and looking at. So how do we actually go about doing this? Well, excuse me. One of the key things is secure coding training for our developers. So as Outpost 24, we partner with a company called Secure Code Warrior, who offer this platform that you can see on the right hand side there, and that's all about presenting developers with real world scenarios, real world challenges, to teach them, walk them through, and teach them how to recognize good coding, good secure coding, and also how to fix issues when they are reported. So regardless of the platform you're looking at, what the key things you need to look for to be successful in a secure coding training program, we need to have the right languages and frameworks that you're using within your organization, not just today, but for the future as well. If you're going to be looking to add different additional languages, additional frameworks, we need to make sure that they're covered as well. So you've got one platform to really get the organization on the same page as far as the training goes. Very important as well as the e-learning videos and walkthroughs are important to get to disseminate the initial knowledge. But then it's very important to have hands-on labs, hands-on challenges, where developers can actually find the real vulnerabilities and then go about choosing the right solution and actually go into coding labs to actually fix those problems. By doing those tasks, those missions and challenges, it really embeds it into the knowledge of the organization, rather than just clicking through some slides, clicking through some e-learning videos. And the Secure Code Warrior platform also allows you to set up a league, I suppose, set up a challenge between team members. If the organization thrives on some competition, or people can just go to be self-paced, go at their own pace to understand where their strengths are, where their weaknesses are, where they need more knowledge. And this is configurable, so we can actually do a lot of this organizational learning that I talked about on the previous slide. We can make sure that is embedded into the training as well, so we get the right knowledge going within the organization. So what are the benefits? What are kind of very quickly some of the benefits? Kind of hinted at most of these, I think, already. But overall, we'll have better security processes, better understanding, quicker time to fix problems if they appear at all, a reduction in the new vulnerabilities, and overall a better relationship between the DevOps and SecOps teams, because there's a better understanding of the security implications. Just to give you a couple of statistics, one organization that used this product found a 90% decrease in recurring vulnerabilities, which is obviously massive from a productivity point of view. And a payment card provider saw a 60% increase in skills within a 3-month period. So very quickly getting that knowledge into the organization, but keeping the knowledge to prevent those reoccurring issues that we talked about. So we've now got we're now in a situation where we've done the planning. We're actually doing the actual coding. One of the key things we actually need to look at now are the other things that our software actually interacts with. And here, one of the key things that we find nowadays is the introduction of APIs, or application programming interfaces. For those of you who aren't too familiar, this is started off being anyway very much a traditional server-to-server communications, so that one organization or one department could actually provide the ability for another department to interact with their software and their applications. And we've seen a significant extension of this over the past few years. Though APIs started off as what I've referred to there as partner APIs. So APIs that were exposed to trusted partners, so they could integrate between the two platforms. Examples of this would include things like, let's say, between retailers and wholesalers. So the retailer could check the stock within the wholesaler and then order stock directly from the wholesaler's system. So cutting out a lot of unnecessary process and speeding up the actual business transaction. Another example would be financial reconciliation between different financial institutions. But basically, we can look at any business-to-business interaction. And in these situations, we knew if I'm opening up an API to another company, I know exactly who that company is. They're a trusted company. I can put them on a whitelist. So the security implications are low. I'm not going to say they're none, because we have had obviously there have been instances where third parties where attackers have used third parties to get into organizations, but limited, because very much limited in comparison to what we're about to talk about in a second. The next use of APIs is typically for exposing APIs within an organization. So this is for data exchange between different departments, business units, divisions, geographic divisions typically in large enterprises or in conglomerates where they've got different systems, but they need to actually have some sharing between the two. And more recently, this has been used to develop web apps, kind of using microservice architectures. So it means that the front-end developers, they no longer need to worry about the details of the back-end application stack, and all of the interactions between the layers are decoupled, which is making it easier. So we've got a loosely coupled, collection of loosely coupled services, which improves the productivity of the developers. And then finally, we've got this idea now of public APIs. So APIs being exposed publicly to offer developers integrations. Clearly, this has a much wider implication. The client-side, using client-side scripting languages to create this idea of single-page applications. So instead of the picture I've got on the left there of a more traditional website using the single-page architecture, more efficient, quicker from a user point of view, and a lot more flexible as well from that point of view. But it is exposing the APIs a lot more and increasing that actual attack surface, which is something we have to be very aware of, that we didn't have to be aware of previously. So if we look at web traffic to organizations is now made up of API calls. So as a result, we need to put a lot more emphasis on API security and API security testing. But we've also found that a lot of organizations, while they maybe have skills in-house regarding, I call it standard web application, traditional web application penetration testing, they don't have anything expertise or tools covering the API side of things. So this is causing a potential security gap or knowledge gap within the organization. So we've, as Outpost 24, we've identified this as being a challenge, and I don't have time on this webinar today to go through in detail. Although I'd quite like to at some point. But we've created a managed service based on API security testing, and that addresses the specific vulnerabilities associated with the APIs. So we've got skills and the technologies to actually dig into the API transactions to look for and report on the vulnerabilities there. So as I say, we haven't got time to dig into that today, but if that is something that is interesting to you, please contact us after this, and we can or put your name in the send your name in the chat, or contact us afterwards. There'll be details at the end, and we can certainly talk about that with you in more detail. Okay, so we're at the stage now where we are. Excuse me. We've got at the stage now where we've developed the application, and we're quite happy that the integrations with our APIs, we're in good position with our APIs. Now, before we actually go to release, it's good, particularly for really critical applications, for us to do an in-depth manual penetration test, particularly on a major application launch, or when there's a major change to an application. So again, as Outpost 24, we've identified that many organizations, they do a traditional pen test of an application, but nowadays the skill, as I was reading this morning, actually there's still significant skill shortages in the cybersecurity industry, and specific knowledge about application security means it can be very difficult for organizations to perform these pen tests before pushing the application live. And that can mean one of two things: either they do a much smaller test and potentially miss critical vulnerabilities, or it actually delays the release of a product, and the whole delays a project because we're having to wait for those skills to be available. So as an organization, we offer an in-depth penetration testing as a service, which will, as it says on the tin, it will actually do the penetration testing for you, and we will post make findings available to you in our portal, and those findings will have, I say, guaranteed 0 false positives. How can we do this? Because every finding that we have is independently tested and is checked by our penetration testing analysts. So they had a look. They've looked over this and made sure that what you're seeing, what's published to you, is actually a genuine finding that you can that you need to act on. And I think this is really important when we're talking about pushing these things back to developers. The last thing as a security professional I want to do is push everything back to the developers and get them to fix it and have them chase. And as a developer, the last thing I want to do is chasing false positives, looking for things that aren't really there or aren't an issue. But with these verified findings, I guarantee that when we're pushing them back down to the developers, these are real things that do actually need to be actioned. And when they are actioned, part of the service as well is a revalidation, validation on retesting of the vulnerability to ensure that vulnerability has actually been fixed before the case is actually closed out. So you can be sure that for the security teams, for any compliance or auditing teams, that we've actually resolved that issue. Okay. So once we've actually done this in-depth penetration test, and we're happy that the actual software itself is free from vulnerabilities, the next thing we're actually needing to do is potentially integrate those at some point with in containers, and actually push them into containers. We've seen that over the past few years, containerized applications becoming more and more popular for a number of reasons. First of all, they increase innovation and speed, supporting a much more agile approach to delivering applications. Developers no longer need to worry about things like standing up a database application. They can just pull it from a repository, pull it from a registry rather, and get up and running. Which means we've got a lot more flexibility and a lot more. It's a lot more cost effective for the organization. However, we do need to be careful. With any new technologies or any technologies, that we need to make sure that we've got the right security in place in an agile approach to actually deal with any security issues that may actually crop up. So here's a simple AWS ECR or Elastic Container Registry example. Very, very simple. I appreciate that in the real world much more complicated than this, but just gives us an idea of what we're talking about here. So we've written our code on the left hand side and created containers that we're actually storing in the ECR, and theoretically they are now ready for the developers to pull out and use in the wider as part of a wider application. But what we want to do first of all is do some static scanning to make sure that what we have in those containers is vulnerability. So by performing the static scanning ahead of making these available in the registry, we can be confident that we're providing the developers with a set of trusted containers that they can reuse. So when they do pull those images, when we pull those images out to run in the production environment, we can be confident that we're not introducing additional vulnerabilities into, we're not introducing any vulnerabilities within the actual containers. And it means that the developers can actually just focus on the valuable tasks that they need to be focusing on, developing high quality code. And you notice on the right hand side there, we can see that we have dynamic scanning. So once we go into the blue area, the production, we then need to start thinking about dynamic scanning to make sure that on an ongoing basis, our applications are vulnerability free. We haven't introduced any configuration changes, for example, or additional libraries or whatever that actually going to cause us any challenges. So if I just, so my final stage here, we're looking at the stage, well, kind of stage 4 and 5, kind of splits between the two. The idea of regular testing and continuous hybrid testing of critical applications. So before we go any further, I'm just going to open up a poll, which we'll look at the results of in a little while. Just curious to understand from you, how often are you currently running penetration testing? So annually, 2-3 times a year, quarterly, monthly, just ad hoc, as I need it, or is it a continuous thing? You're constantly running it on a on an ongoing basis. So we'll leave that poll open for a little while, just so you can actually go through that, and we'll come back and look at the results in a little while. So how often are you currently running penetration testing within your organization? From annually, because I guess that's what we need to do to meet compliance, or 2-3 times a year, or are you looking at more continuous, a more continuous situation? I'm going to say we'll come back to that in a short while. Okay. So to give the game away a little bit with the poll, but so basically we do have a choice as to how we want to, how to do how we're doing penetration testing, how we're doing scanning of our applications. I can do a periodic scan, maybe annually, maybe every quarter, 6 months, month, whatever's required. Typically, whatever's required from a from a requirements from a compliance and auditing point of view. It's requirements of once every 6 months, do a basic scan, and that's for many applications that may be good enough. Whereas for other applications that are maybe more critical, I maybe want to do more I maybe want to do more testing from that point of view. So how do we decide which type of testing we actually need to do when we need to do penetration testing? When do we need to do manual penetration testing? Penetration testing on a periodic basis based on that, or when do we do continuous testing? So we need to look at the criticality of the actual application itself. So basically, what I was saying here was that we need to be looking at, are we going to be doing a penetration test on a one-off basis, or every 6 months, every quarter, or are we going to be doing a continuous testing? So that's going to be very much depend on the business criticality of the app, of a few things: the business criticality, the update frequency, and the complexity level of the organization. So If the application is revenue generating, then clearly that makes it a much more critical application. Similarly, if it's hosting critical information, personal information of customers or employees, or maybe it's actually holding our intellectual property as well, then that's going to bump up the criticality of the application. Similarly, if we're updating the application on a regular basis, then we should be doing testing on a more. If we're doing, if we're releasing every 2 weeks, then we should probably be looking at doing testing on a more regular basis. Whereas if it's a less critical application that's only being released, only having new release every 6, 12 months, or only being significantly changed in every period of time, then there's probably no need to do quite as much testing from that point of view. And finally, the complexity level of the application. If this application is very, very complicated, many pages, lots of dynamic content, then that's something else that we actually want to be taking into consideration and making sure that we're testing often enough from that point of view. So by putting these three factors together, we can then determine whether we're going to do I've called it a traditional penetration test, where we're looking at something at a point in of the organization of the security situation at that particular point in time. Useful to do, but and as I say, very good for ensuring compliance if we have to ensure compliance, but can be quite labor intensive. And I mentioned earlier on, if we have a lack of skills, it can actually delay getting those findings and producing those reports for our auditors. And it's also quite difficult as well to keep up with the rapid changes. If the application is changing on a constant basis, then it can be quite difficult for us to make sure that we're keeping up to date with our security, keeping on top of all of those vulnerabilities. So the alternative here is for us to actually look at a continuous service being actually oops, too many, sorry. Providing a continuous monitoring service of business critical applications. So those applications that we have to be critical. And you can see there, quite a screenshot, hours 24 penetration test as a service. We will continue monitoring. You can actually see what is happening on the so we can see happening in the port ongoing basis. If we see issues there on the query, just right click there. You can actually talk with the team, with the penetration testers, and what's happening there and how you go fixing it. If you click to each of those, I'll see we'll get some information about ability, how to create that vulnerability. And I can also do things again. I can actually buy our security penetration testers, and I can ask for retests when I'm if I'm not happy with the. I can ask for retests when I am happy that I've found that I've resolved the issue, so that they can be tested, and we can actually sign those off as being fixed. So as I mentioned, what we're actually doing here is we're actually able to decide between the two different types of of penetration test: the static one-off penetration test, or a longer ongoing. I'll refer to it as a hybrid test, which is a combination of automatic testing and and the facilities of the penetration testers to look over those results and verify that they're actually genuine genuine issues that need resolved. So, in summary, what we've actually gone through here is we've kind of gone through the whole of the software development lifecycle, starting off at the very beginning, looking at planning, making sure that we have our security testers, our coders are trained up properly so they can actually code efficiently and securely, and also find vulnerabilities if they are reported by the DevSecOps team. Considering API testing, making sure that we actually have the tests, make sure that we actually have them tested, as they could present a significant vulnerability to the organization if we don't manage the security around those properly. And then before we actually go out into the production environment, making sure that we have in-depth manual penetration test, so that we can check that we're not introducing any vulnerabilities before we actually go out into the release phase. Then when we're releasing, if we're relying on containers to pull in databases or other elements, checking ahead of time that those are clean from vulnerabilities, so that infrastructure that we're actually providing they're actually providing the developers and the production environment is a sound infrastructure that we can rely on. And then finally, as we move into once we've gone through the deployment to the operation and ongoing operation and monitoring of the application, doing different kinds of penetration testing, either the one-off testing or periodic testing, or the more continuous tests to actually make sure that we are keeping on top of any vulnerabilities that may be introduced. So those are the key areas that I wanted to talk about today from the software development life cycle. But there are other areas that fall slightly outside of the SDLC, but I still think they're very important for us to actually mention. Because they form part of our overall security posture. So first of all, I kind of hinted a little bit earlier on this idea of risk-based vulnerability management. So organizations that are looking at vulnerability management come to me and say, I just get swamped with too many vulnerabilities. Even if I start prioritizing, looking at things like the CVSS score, if I look at the highest levels of CVSS, the highest numbers on the CVSS scores, there's still far too many for me to actually go and fix. How can I get around that? So we actually, within our RBVM solution, we actually look at a lot more than just the vulnerability score. We do scoring based on things like how likely is that vulnerability to be exploited. How much has it been talked about on the dark web, for example? Is there an actual exploit that exists, and is it something that could attack you, that is likely to be attacked in your organization? And then using that information, we've got a build up of more information. The scoring we give can be much more accurate, so we can then focus on those things that are more key. And as I said earlier on, if I'm getting developers to fix vulnerabilities, I want to make sure that the vulnerabilities I am sending them are the right ones. Indeed, if I'm getting anybody to fix vulnerabilities within my organization, I want to make sure that I'm focusing on the right ones, the ones that are going to have a negative impact if they're not fixed. One of the other areas to look at is the external attack surface management. So it's all very well us doing penetration testing and securing what we know, but what about the parts of the infrastructure that we don't know about? The example I always give, being in marketing, I'm allowed to, is that marketing, create a marketing campaign to customers, set up a separate website, link it into our customer database. Think they're doing the right thing, being agile in the best sense of the word. But are they actually exposing our organization knowingly or unknowingly to bad things. Potentially, if they're connecting to the database through what's essentially a backdoor. So being able to detect this whole external attack surface that is non-sanctioned by IT and by security is very, very important. So we can actually bring that into the security processes and manage those. A whole host of other things as well. That the external attack surface that even the things we know about could expose us. So very important to get a grip of the entire attack surface. And then the final point there, cyber threat intelligence, our threat compass product, basically giving you a broad range of information about the threats that are out in the wild, and then how they could relate to you and affect your your organization from that point of view. So giving you the power to actually get ahead of the threats in the organization, so you know what to be aware of from that point of view. So there's just other areas to think about that are slightly outside of the SDLC, as I say, but I think very important to think about, because at the end of the day, as I say, they're still a key part of our security posture. So in summary, just again, looking at the SDLC across the top, that's just kind of a summary of some of the tools, some of the things I mentioned today and where they fit in. Clearly, it's not a single tool across the board. There's a bunch of tools across the tools and solutions across the SDLC that we need to look at. All very, very important, from making sure that developers are coding securely, all the way through to the ongoing monitoring and testing from that point of view. So with that, I'd like to thank you for your time today. I'd like to apologize for the internet gremlins we experienced there, and I'd just like to open up for any questions. If anyone has any questions, we got time for probably one or two questions. Okay, there is one.
Stuart,
yeah,
go ahead. Go for it.
I was going to say, yeah, one's just coming now. Actually, the question about the secure code warrior. I don't manage the dev team, so in the security side. How do I get them on board with the training? That's a great question. Challenge. It's definitely a people challenge rather than people and process challenge. I would say that it's key to understand their workflow, get on board with them, start early in the discussions, try and find advocates within the organization, security advocates in the development team, and dialogue is key. Make sure that it's not a them and us situation. It really is. We're all on the same side, wanting to develop secure, professional software. So getting them on side and having the and before even introducing a security training program is absolutely critical. So yeah, great question and a very valid point. And
so Stuart, we've got one more question that just came in, actually. And how effective is pen testing as a service, and how can it handle a number of false positives?
So how effective? I'd say, obviously, very biased, but very, very effective. And the answer to the how do we deal with the false positives? So rather than having to sift through them myself as a security analyst to work out which are false positives and which aren't, we pass all of our findings through our own pen testing analysts. They review those to make sure they can be recreated in your environment, as a customer in your environment. And if they can't, then we'll class them as a false positive, and you won't actually see them in the portal. So the vulnerabilities that you see listed in the portal, those have been verified by us as not being false positives and are real vulnerabilities that we actually need to deal with.
Awesome. Well, that ends our questions, and we are about out of time as well, Stuart. So I just wanted to thank you so much for joining us today on Techstrong Learning. And thank you also for joining us on screen as we close things out. Sorry I had to turn your camera off to save a little bit of bandwidth.
That's okay.
Awesome. So I would like to remind everyone that we've been recording our session today. You'll be receiving that via email as soon as it's available, but you can also find it living on the DevOps website at devops.com/webinars. The two winners of our $25 Amazon gift card drawing are Hillary M. and Sue M. So to Hillary and Sue, I'll be contacting you here shortly via email to get your gift card over to you. If you don't happen to find an email from me, check your spam folder just in case it happens to be filtered out. I'd like to thank Outpost 24 for sponsoring our program. And to our audience, thank you so much for being here with us today. We appreciate your time, and we would love to hear your feedback via a survey link that I posted there in the chat. So yeah, just a second to fill that out for us. We'd really appreciate it. Otherwise, we hope to see everyone at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Stuart, thanks again.
Thank you very much, everyone. Thank you.